Good morning everyone, myself Dr. Poonam Singh. Today I will teach you spectroscopy. It is a new topic for BSc second year student. Okay, it is a branch of chemistry in which deal with the structure of compound, the interaction of electromagnetic radiation with the matter. Okay. Before this we used classical methods in which there is large steps to determine the structure analysis. First we do element detection, then we get the empirical formula, then we calculate molar mass, and then after that we get the exact molecular formula. It takes too long time. Okay. So spectroscopy gives the better results, require less time, it is highly reliable, and it sample remains unchanged. Before going into the detail of spectroscopy, let us discuss about electromagnetic radiations. How electromagnetic radiations interact with matter. So, we need to understand the nature of electromagnetic radiation. Electromagnetic radiations. Electromagnetic radiations. As name says, it is the mutual interaction of electric and the magnetic field. So, it consists of oscillation of electric and magnetic field, right? These are different forms of energy, like example UV, X-rays, gamma rays, etc. They have different wavelength, they possess different wavelength, or you can say they are characterized by their definite wavelength, wave number, and frequency, and the frequencies. Okay, electromagnetic radiations travel into the space, is transmitted into the space, has enormous energy or velocity. Okay, these electromagnetic radiations are quantized. Electromagnetic radiations are quantized. That means they are packets of energy, like they contain quantums. Quantums are the bundle of energies, and they possess energy in the form of photons. One photon is h mu. Okay, one photon is h mu. So these are all the points about electromagnetic radiations. One point is also important. It is, according to quantum mechanics, it says electromagnetic radiation behave as a dual character. What dual character means? They behave as a wave as well as particle. So these are the whole about electromagnetic radiations. There are some parameters of electromagnetic radiations. These parameters are wavelength, wave number, frequency, and the energy. Wavelength is, wavelength, this is a wave, fine, wave. So wavelength is defined as it is the adjacent distance between two crusts. These are crusts and it is troughs. So adjacent distance between crust or adjacent distance between troughs is wavelength. Okay, it is expressed by lambda. Sign is this. It can be expressed in angstrom, right? In a particular wave, adjacent distance between two crusts, adjacent distance between two curves is lambda. Lambda is expressed by this sign lambda and the angstrom. There is a one relation in between the angstrom and the centimeter. 1 angstrom is equals to 10 to the power minus 8 centimeter inverse. 1 millimicron is equals to 10 to the power minus 7 centimeter, right? The ultraviolet radiations ranges from, this is an important point, ranges from 3600 angstrom to 7600 angstrom, right? This is the ultraviolet radiation ranging. Ultraviolet radiations can be detected by photoelectric set. Wave number can be defined as the total number of waves which can pass through a space of 1 centimeter. Wave number can be expressed by nu bar. It is nu. It is the reciprocal of wavelength, right? And this wave number is expressed in this nu. And wave number, it is important for the IR spectroscopy. The IR light can be detected by photographically. Okay, photographically, right? And mu bar is used in the IR spectroscopy. The electromagnetic radiation which is absorbed and in the form of frequency. This is wave number, nu bar. Now frequency, it is expressed is nu. It is the reciprocal of wavelength. As you see, frequency is the inversely proportional of wavelength. So greater will be the wavelength, smaller will be the frequency. Right? If we define frequency, so frequency can be defined the total number of waves which can pass through a point in 1 second. So it is expressed in cycle per second. Frequency. Okay. Now energy is packets of energy which are coming from in the form of quantas. Each quanta have the different electromagnetic radiations, that is photon, and this energy is associated with the single photon, that is E is equals to h mu, right? H is the Planck's constant. And we can also write this nu is equals to C upon lambda, where C is the velocity of light. So these are the parameters of electromagnetic radiations which is used for different spectroscopies. For the ultraviolet spectroscopy, wavelength; for IR spectroscopy, its nu, frequency, और NMR स्पेक्ट्रोस्कोपी के लिए भी हम किसमें नंबर ऑफ प्रोटॉन्स कैलकुलेट करते हैं. Yes, electromagnetic spectrum, if we arrange all the electromagnetic radiations according to their wavelength and their frequencies, so it is called the electromagnetic spectrum. I have arranged on the basis of their increasing wavelength. So radio waves has the higher wavelength, and then microwaves. Infrared region lies in between the microwave and between the visible region. Infrared region has the greater wavelength as compared to the visible region and the UV region. Visible region is that region in which we can detect, we can identify the colors. What we see, we can see through our naked eyes the colors in the atmosphere. The colors we can see, it is lies in the region of visible region. Ultraviolet region, and then X-rays and the gamma rays. As you know, wavelength is wavelength and frequency. What is the relation in between wavelength and frequency? They are reciprocal to each other. Frequency is reciprocal to the wavelength. as the wavelength is increasing towards the radio wave region. So frequency will go down. Okay, so radio wave region has the greater wavelength and frequency will be less. One more important thing is this, कि if this frequency increases towards the gamma rays, then energy will also increases. Frequency increases and energy will also increases, as you know E is equals to h mu. Frequency is increasing towards the gamma rays, so energy will also increases, right? Energy increases if we move towards gamma rays. Now gamma rays is that region in which we study about nuclei, nucleus. X-rays are the region where we study about the thermal imaging and the X-ray machines. X-ray machines. It is used in the medical diagnosis. And gamma rays is also used in the medical diagnosis. It is also used in the cancer therapy. Visible region is that region in which all the colors are visible. It is, we can see the colors. The colors is, region is VIBGYOR. Okay, violet has the what? R is the red and that is higher wavelength. And the violet is the blue and it is lower wavelength. These are the colors by which we can see. These VIBGYOR has the definite their wavelength. The particular wavelength describe its particular color. V, violet, indigo, blue, green, yellow, orange and red. Okay. Infrared is the reason it has the greater wavelength, lower frequency, less energetic as compared to the gamma, X-ray, UV and visible. Infra is a reason in which we use for the identification of compounds, thermal imaging. It is used for the thermal imaging. Okay. And microwaves and radio waves is the reason. Radio waves is used for the communication. And microwaves is the reason which is used for the radar. Okay. The communication is what? Data communication, radios, FM, television, remote control. This is the one-to-one. This is the communication to all. Radio wave and the microwave are the reasons. These have the longer wavelength and lower frequency, right? Radio waves, as you listen radio, FM, music, TV, all are depends on these radio waves, electromagnetic radiations. These are used for the data communication, voice communication, telephone communication and that high bandwidth communications, right? If radio wave reasons, if we say, so you should know about one thing, the radio waves reasons, electromagnetic radiations can penetrate through the wall, right? And but visible and UV reasons cannot penetrate through the wall. So okay, so it has a limit. They can only work on that, like UV is only work on that molecule, like X-ray only work for the atoms, and gamma rays can work on nuclei, okay, till nuclei. And visible is that reason, as you know, we can visible all the colors in that regions. And infrared regions, what happen in the infrared region? If any compound absorb this infrared region, then molecules get excited, absorb, they vibrate and rotate and gives the information if we talk about the organic compound, right? And microwave regions, in the microwave regions what will happen, as we use the oven in our house to heat up our food. So molecules of food heat up and gain energy, and that gets heated up because they absorb energy and gets oscillate, exchange energy and gets heated up. And radio wave region, अभी मैंने आपको बताया, it is used for the communications, for the telephone communications, for the FM and okay. In spectroscopy, there is some energy change. When any sample compound absorbs particular wavelength, particular electromagnetic radiation, it gives its information. It depends on their selection rule. If it absorbs ultraviolet radiation, so it gives information about the bonds, saturation and unsaturation. If it absorbs IR radiation, so it tells us about the functional groups, which functional group is present in particular organic compounds, right. If it absorbs radio frequency region, so it gives information about the number of protons and number of carbon, protons and carbons में बताएगा. So it is NMR spectroscopy. If it absorbs ultraviolet, then it is ultraviolet spectroscopy. If it absorbs IR radiation, then it would be IR spectroscopy. If it lies in between the radio frequency region, then it would be NMR spectroscopy. Okay. Thank you so much for watching my video. Please like, share and subscribe ANP tutorial. Till then, bye bye.